Yours now.
All right, great. Thank you, Ingo. Yeah, hi everybody. Great to be here. Thank you for inviting me. Yeah, so it's a pleasure and a privilege. Let me just share my screen. Just put it in presentation mode. Okay. All right, good. So yeah, apologies for the slight delay getting going there. Not entirely sure what went wrong, but we're here now and you can see my slides. So what I'm going to present over the next 20 minutes or so is some reflections on some work that I've been doing with various colleagues over the past 3 or 4 years at the intersection of information retrieval, natural language processing and user experience. And there's some thoughts here that are sort of pragmatic about the profession of, well, information science in particular. And then there's some thoughts that are possibly a little bit more controversial. Okay, so let's get started. So, oh yeah, you've probably done a little bit of my background already, Ingo, so I won't say too much about this. But for those whom I've not met, I've worked at the intersection of information retrieval, NLP, and HCI for a little while, a couple of decades, possibly a bit longer. And I've kind of had a foot in both camps of academia and the sort of practitioner world. I've worked for various. I was originally an academic, but then worked for a lot of different R&D labs, and actually found my way into consulting and professional services. So I've seen a lot of different sides of the information retrieval industry and seen it from various perspectives. So now I kind of mix my time between academia and also I run a small sort of what you might call boutique consultancy and do a couple of other little things on the side to do with spin-offs and startups. And it's kind of that thread that I'm going to focus on today for the next 20 minutes or so. So to get us all started then on the same page, I'm going to talk a little bit about something that I think has been referred to by some of the previous talks. Martin White's talk in particular touched on this, the concept of professional search, right? So, you know, when we think about search, we all use it. It's woven into the fabric of our everyday lives. We touch on Google and Bing and various other search engines during our daily lives. And if we don't find what we want on one, we can go to another, and it's a fairly sort of discretionary, sometimes pleasurable activity. But I want to draw a distinction between those use cases and the other ones that are out there, which are actually a little bit more serious, a little bit more work focused, a little bit more what you might call professional. So by that, I'm referring to people that work in, for example, patent searchers, or healthcare information professionals, and even folks who work in recruitment. If you've ever had a phone call from a recruiter saying, I've got this perfect position, yada, 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 and they've got this spec that actually occasionally matches your own background, and you put the phone down, you're wondering, well, how did they find me and how did they put the two of us together? It generally tends to be through professional search, and I'll give a couple of examples of this in a moment. And then there's media monitoring as well. A lot of companies rightly care about their reputation, and they invest a lot of time and money in monitoring that reputation. And as a result, the way they do this is typically through complex searches that are essentially scouring the web and monitoring the web on a continual basis for instances of products, people, services, and other competitors that they're interested in. So for these kind of individuals and organizations, keyword search isn't good enough, and instead we need something that's more professional, and that needs to be comprehensive and repeatable and transparent. So you're probably thinking, well, okay, I sort of know what you mean, but can you give me an example? So this is a typical example of what you might call a professional search tool. Funnily enough, actually, this is actually the subject of a significant reworking at the moment, and one of the things on my to-do list is to get involved in to dig a little bit deeper and find out how they've improved this. But suffice it to say that this is what's called the International Clinical Trials Registry Platform, and this is a classic example of the genre. It's a line-by-line query builder. It's kind of a form-based approach. It encourages you to articulate keywords and control vocabulary terms, and to connect them using Boolean connectives, and then to add various other fields, and then basically to press search at the bottom. So it's a classic sort of form-based query builder. And these things create artifacts like the following. You can see on the screen here, this is what's, for those who aren't familiar, this is what's called a search strategy. You can almost read it. You can see that it's composed of 33 lines, and a significant number of these lines are what you might call keywords, but there's some controlled vocabulary terms in there as well. If you understand the syntax, you can spot these. But I think the most interesting thing about it, well, there's two interesting things. One is there's quite a lot of Boolean logic in there. If you look at line 8 and line 10 and lines 31 to 33, and various others, 17 and 22 and so on, that's the glue that holds all the content together. But more importantly, it's the interesting observation, well, I think it's interesting, is that the line numbers are actually used as the reference. And those who are old enough to remember first generation BASIC may actually see a certain parallel here in the use of line numbers as the way to glue code together. And we might just want to reflect on how the software industry in particular has changed since then. And that's a theme that I'll come back to in just a moment. But this is a genuine search strategy. This was published, and you can see the reference there below. So, you know, when all of us go and get clinical support, clinical interventions, they're based partly on the judgment of the professionals involved, but to a significant degree based on the judgment of best practice, or the evidence base, which is gathered through health search strategies like this. So just briefly, I'll talk about, as I said, it's not just healthcare. If you actually look, if you type Boolean strings into your favorite search engine, you'll probably find 9 out of 10 of the first 10 links are actually written by recruiters. So they call themselves, there's a whole subculture in the recruitment world called Boolean black belts. Seriously, and they love this stuff. They live it and breathe it, and they kind of pride themselves on cultivating a skill in crafting Boolean strings, and that results in the return of social profiles like this. So this is exactly how recruiters find you when the phone rings and you're wondering, well, where did they get my name from? So as I mentioned, it's not just recruiters. There's also a significant investment in the intellectual property industry and patent search in particular. And they use a similar approach to the line-by-line sort of imperative approach that we just saw, or procedural is the right word, really. Procedural approach that we just saw, where you can see here there's 12 lines, 1 to 12. And again, you've got controlled vocabulary terms along with keywords, and a significant amount of Boolean glue holding it all together. And then there's media monitoring. So here's an example of a genuine media monitoring string or search strategy or query, call it what you will. And you can see that that again is fairly complex, and some of the complexity is reduced by the effort that I think I may have made in what we call pretty printing or formatting that. And you imagine if you take that away, it gets significantly more dense. Incidentally, just as a little thought experiment, going back to this one, I would invite you to take a moment to read that and to try and conceptualize what that would look like in terms of conceptual blocks. If I was to tell you, those of us who've been exposed to what you might call training in information science would understand that an information need is typically broken down into facets, and those facets represent different aspects of the information need. So if we were to ask the question, well, how many facets are there here? I'm just wondering how many people might get that right. So I'll just leave that hanging there for a moment, and that's a thought I'll come back to in a bit. And likewise, there's something a little bit odd about this search strategy. I'd been given this by a patent search colleague 5 years ago, and I'd used it in various talks for various examples. And it wasn't until I sort of in a rather ad hoc moment visualized it, and I'll talk more about that in a moment. About a year ago, I realized there's something odd about this one too. And again, I'd invite you to have a look at it and see if you can see what it is that's just a little bit odd and may actually be a mistake in that search strategy. And again, feel free to put it in the chat window. I'm not sure I can see, oh, I can see the chat window. I'll move that out the way. So if anybody wants to have a little go at that. All right, so these things get pretty complex. Here's an example from media monitoring. This one was actually 10 times the size of this, and I tried to copy it into PowerPoint, but PowerPoint crashed. So I've just given you the first tenth of it. So they can get quite complex. So what I want to do for the remainder of this talk, obviously there's a number of use cases, but I want to focus on one in particular, and that's healthcare. Now, I mentioned a moment ago that when we visit a healthcare practitioner, or even when we just want to know what is a healthcare best practice, like what is the evidence around the use of face coverings in public, what is the evidence around the safety of the AstraZeneca vaccine, and so on. People don't just, well, they shouldn't just ask each other's opinion. They should gather the best available evidence. And where does that come from? It comes from scholarly literature. And the process of gathering that scholarly literature is what's referred to as a systematic review. So it summarizes the results of healthcare studies and provides a high level of evidence. And that then forms the evidence base for best practice in healthcare. Okay, so far so good. And then we look at the evidence base itself, and it really doesn't sort of matter how you measure it, whether you look at the number of trials or look at the number of systematic reviews. You tend to see a relationship, a function like this, which is essentially some sort of power law going on with ever increasing availability of evidence and growth, and here you see the growth in systematic reviews over the last 25 years. So that's all good as well. We've got lots and lots of, we've got an evidence-based approach, lots of data. How do we manage it? Well, great, more good news. We have something called the PRISMA flowchart, best practice in the information science community for filtering this information overload, taking a large amount of information, screening it for eligibility, and then getting it down to a reduced set that is then included in the systematic review. So we've got all this data, we've got a process, we've got evidence-based medicine. What could possibly go wrong? Well, it actually turns out that there is a little bit of an elephant in the room here, in the sense that the good old Boolean string, which has been the kind of bedrock of professional search ever since professional search became a thing, before it even had a name, is actually remarkably ineffective for communicating structure. And of course, there's no irony there because we use it for structured search. So how does that work? But the point is, you saw the examples. Without those visual cues, it's incredibly hard to see the structure in the Boolean string. And more to the point is actually, going back to what I was saying about first generation basic, one of the reasons languages like that died out was because they weren't object oriented. Well, they had various other flaws as well, but they had no inherent facility for managing complexity. And by that, I mean, they had no facility for abstraction or encapsulation or inheritance, but that's another issue. They had no facility for managing the complexity. By the way, Udo, I'm hoping you can still hear me. The little Zoom window just vanished. Can you still hear me okay?
Yeah.
Yes,
I can.
Okay, that's good. For some reason, the little Zoom window just said bye-bye and vanished off my screen, just to keep me on my toes.
Very interesting. How did you do that? Nice.
I don't know. There's somebody's controlling my laptop. Very odd things going on here. Anyway, as long as you can all still hear me, I know you can't see me, but you can see my slides and you hear me, so that's the main thing. All right, good. Let's continue. So as I was saying, yeah, the elephant in the room is the Boolean string is actually, in my opinion, not fit for purpose. It doesn't display any of the attributes that we would want a robust, scalable representation to possess, such as abstraction and encapsulation, and ideally inheritance as well, but I'd settle for just abstraction, to be honest. And the third point is that even if you don't sort of buy into the analytical argument that this approach is not fit for purpose, there's actually a very strong empirical argument, which is that when audits have taken place of search strategies that have been published, that have led to the evidence base upon which most of the Western world now relies, there's a remarkable number of syntactic and semantic errors in them. And there's this paper from 2019, which does a very effective job of outlining the extent of those errors. And there are other papers from 2006 which have revealed that 90% of the search strategies they sample contain one or more errors, which is quite a shocking statistic, really. And it kind of gets a little bit worse if you dig a bit deeper into professional search practice. And again, these observations are courtesy of Farhad Shukrani, who is a professional systematic reviewer based at King's. He makes very articulate makes the case that search strategies need to be peer reviewed, but there isn't an appropriate format for that. The way in which search strategies are reported are in document-centric formats, for example, using word processors like Word, which auto-convert the very important diacritical symbols into words trying to be helpful, but it turns them into other things, which then mean that the search strategy is corrupted, essentially. So there's all sorts of things: correction of truncation and wildcards, auto space removal, and so on. And PDFs is another popular format for reporting search strategies. And again, if you've ever tried to copy text out of a PDF and into some other system, it comes with all sorts of invisible baggage attached. So there's clearly an issue around reproducibility. There are then a whole host of issues around the colloquial understandings of Boolean operators, like the colloquial understanding of and is as a cats and dogs would be as a conjunction, whereas of course in Boolean logic it's a disjunction. And cats or dogs is perceived as an exclusive or colloquially, whereas to a Boolean parser, it would be, of course, be a disjunction. And then there's issues around translating these search strategies for the evidence base to be gathered appropriately. Numerous databases need to be consulted, often with their own proprietary syntax. So there is a considerable overhead, manual and error-prone overhead in translating search strategies. And then there's further issues around sharing them. The fact that they're shared typically as supplementary materials, which tend to get detached from the review to which they were associated. And a whole host of issues around the management of those search strategies. So I'm probably going to skip this little bit in the interests of time. I normally do this when I'm kind of face to face with people. It's just a little bit of comic relief. I like to play the little game of showing people an interface from 10 years ago and showing an interface from today and getting them to say which is which, and most people get it right. And then I show them the equivalent, that's from the sort of software engineering community, and then I show them something from the professional search community. I show one from 10 years ago and I show one from yesterday, and nobody can tell the difference, and everybody has a little bit of a chuckle about that because it's almost impossible to tell which was which, because it basically hasn't changed for 10 years or even the 10 years before that. Which may not be a bad thing in itself if it was perfect. But of course, the argument I would make is that it's far from perfect based on the analytical evidence and also the empirical evidence. So the question is, what can we learn from other disciplines? And going back to the thread about thinking about how the software engineering community has evolved over the past 50 years. And just reflecting a little bit upon the nature of search strategies, which, as you've seen, are complex logical constructs. They're read many more times than they're written. Even if the language doesn't support it, at a conceptual level, they exhibit abstraction, modularity, and encapsulation. They need to be maintained, shared, and optimized. Does this ring any bells? Of course it does. It's exactly all the things that we take for granted in the software engineering community, and we've built up processes, techniques, and approaches for dealing with this complexity. But in some ways, and this is the contentious bit, I do feel as if some of the practices in the professional search community are a little bit like how software engineering was done in the 1980s. So that really leads me to the kind of title of this talk, which of course is a play on words with Daniel Kahneman's book, Thinking Fast and Slow, in which he puts forward the idea that the brain can really accommodate two ways of processing or thinking. There's a kind of immediate, intuitive, rapid approach, which is very, intuitive, I guess is the right way of putting it. And then there's a slow way of thinking, which is procedural and is meant to be rational and requires a lot of effort and a lot of cognitive overload. And we think of ourselves as being rational human beings, but actually when you look at it in any detail, we actually find out that that side of the brain isn't as rational as we thought, and it is actually remarkably error prone. So this distinction between the fast thinking and the slow thinking is something that I think is like a little bit of a repeating motif or metaphor for the evolution of what has or hasn't happened in the professional search and more broadly information science community over the past 50 years or so. In as much as the paradigm is essentially what you see on the left here. You've got slow thinking, you've got a procedural approach with static monolithic strings, and instead I think a lot of the issues that we're seeing that could be addressed, and I think the future lies really in what we see on the right with declarative interactive executable objects. So that kind of leads me to, okay, so what do you actually mean in practice? Because that's it at a conceptual level. And this really relates to the sort of thinking that we were doing a few years ago, saying, well, hang on, is there another approach? Could we visualize search strategies? Could we use metaphors the user already understands? Could we take this task apart, have keyword selection on one hand and the query manipulation on the other? Could we do all the things that we take for granted in the software engineering community around debugging and scratch pads? Could we provide instant feedback? Could we reinvent the language to support the attributes that we wanted to support? And could we do pragmatic things like query suggestions? Now, I should point out that we're not the first really to ask these questions, and I'm going to gloss over 30, 40 years of progress in 2 slides. I'll just draw your attention to a couple of things. Back in 1989, there was an attempt, Anik et al., to reinvent the idea of expressing Boolean search strategies using a two-dimensional canvas with visual tiles that could be manipulated, and had a left to right reading, which was fairly intuitively mapped onto conjunctions and disjunctions, and that they could use inverse video to express negation, and you had hit counts in the corner. Lots of quite a prescient piece of work, lots of interesting ideas there. And subsequently, Fishkin and Stone in 1995, thinking about Boolean search strategies as a collection of filters that could be overlaid upon each other. And more recently, we have this tool here, Boolio, which is actually invented by and for recruiters. You can see an example of the input is in the grid and the output is in the string below. And similarly, this work here from David Newman from Exeter, one of the libraries, apologies David if you're on the call, but it's one of the libraries at Exeter, maybe Exeter University Library. So done some very interesting work around, again, using a grid-based metaphor for articulating the complexity of search strategies. And of course, there's the work from the University of Queensland, Harry Sells and co, done some very influential stuff around making search strategies more transparent, more explainable, and more robust. And they've used a tree-based metaphor that you see over there on the right. So that leads me to the work that myself and colleagues have been doing over the past 2 or 3 years, where we've built a tool which encapsulates some of the ideas that we just talked about, where concepts or objects on a two-dimensional canvas and relationships can be expressed through direct manipulation, which designs out the issue of syntactic ambiguity and syntactic incorrectness, because you can only form syntactically correct expressions. So this idea of missing a bracket or a trailing bracket being in the wrong place is designed out. And arguably the semantics are more transparent, and this also supports arbitrary levels of abstraction, because you can expand and collapse these various units. So we like to think of this as a bit like a Lego analogy. You know, it's kind of you can build things of arbitrary complexity, and nothing ever breaks. You know, you can just undo and redo and mold things into whatever shape you like. And you can always go back to where you were before or save it. So it's kind of like almost a playful interaction that we're trying to encourage here. So at the moment, that's kind of how it works from a user experience point of view. From a pragmatic point of view, it's been deployed a couple of years now. We have integrations with 10 different databases, and that number goes up with every release. It kind of raises the question, could you have a universal representation for information needs? We have what I'd call an 80 or 90% solution, but there's other things around proximity and other kind of more complex relationships that are tricky to represent visually. But I think there's possibly a PhD project in there for somebody who wanted to take that forward and, you know, do the last mile, so to speak, which is always the most tricky part of any problem. There's lots of error checking built in to help people. You can see the little example over there on the right with the error message here, giving the user some support as to what went wrong with that search strategy. And you can see translations here, automated translations under each of these drop downs here on the right. But we recognize that even though this is a new approach, we need to support interoperability with legacy formats. There are thousands and thousands of published search strategies out there. So for that reason, we've built functionality that allows you to read in existing search strategies and visualize them on the canvas, which incidentally leads me back to that point when I showed you the healthcare strategy right at the start and said, how many facets are in this? I will show you now. If you visualize it, that's what you get. Clearly, there are 4 facets to this. You know, the labels incidentally are mine, my own interpretation of what the searcher intended. But you can see quite transparently, and back to the sort of fast thinking analogy of Daniel Kahneman, that we have a block over here that refers to the type of study. We have a block over here that refers to the target population, a block for the intervention, and a block for exclusions. Oh, incidentally, I've asked this question many, many times, how many facets are in that search, and I'd probably say that I've had about 50 answers. I can't see the chat window now, so I don't know if anyone's answered, but only one person has ever got it right. And nobody has ever actually figured out what was wrong with the pattern healthcare strategy. But but you can see here that actually line number 5 is a duplicate. And at first I thought that was a mistake on our part, but no, go back to the original search strategy. You can see line number 5 is referenced twice. Now, like anything in code, it's hard to know whether that's what the person originally intended or not. You'd have to ask them, but I would wager quite strongly that that is probably a mistake, and it's persisted all this time until somebody actually visualized it and said, hang on, this just doesn't look right. But the point is that it wasn't until we were able to give this new view, this new perspective on this legacy object, that suddenly the errors and inconsistencies became abundantly clear. So to wrap up, where this leaves us is that we've proposed some design principles around transparency and explainability and reproducibility in professional search. I won't read through these now, but they were fortunately made their way into the public domain through a paper that I did with Andy McFarlane last summer. But in the interest of time, I'll just move on sort of to wrap up. So what I presented today is kind of part conceptual, but part also pragmatic, a tool to solve a problem. But I should point out that I think the problem is more than just the tooling. The interesting opportunity going forwards, I think, is not just around this top blob here, around give people tools and hope for the best. It's also around the other bits, the ecosystem around that. It's the provision of somewhere for people to get content. So if you think in the software engineering community, that would probably be GitHub and associated resources. And somewhere for people to ask questions as well, which again, in the software and computer science community and various other communities would be the equivalent of Stack Overflow. So I think those are yet to be built, but there's a real opportunity there. So to wrap up, what we've spent a little bit of time doing, as I said, thinking, searching fast and slow, it's reimagining advanced search, reimagining professional search, designing out the syntactic error, making the semantics transparent, and then providing pragmatic support for practitioners around reuse, optimization, and best practice. The play on words with the title is, as you see there, it's going from the things on the left, which I think of as slow thinking, to the things on the right, which facilitate fast thinking. If you want to try it for yourself, the link is there. There's a ton of tutorial videos, but I'm conscious that I'm probably out of time, so I ought to stop at this point. So thanks very much, and I'll take any questions.